This lesson is going to be on circles. This is going to be a different way than you guys have seen circles before. I'm going to show you guys what the equation for a circle will look like. So for example, the equation of a line, y equals mx plus b, the equation of a parabola, y equals x squared. Circles have an equation like that involving y and x, and that's essentially what I'm going to show you how to do. This lesson is important. It is typically, I think I've seen it on every ACT, some form of a question about a circle. And the nice thing about these questions are they are not super difficult to solve. Okay, so we're going to go through how to graph a circle based on an equation, and then after that we're going to go through how to look at a graph and tell what the equation of it should be. So starting out with circles. So by definition, a circle is a set of points, x and y, at a fixed distance r, that's going to be important, from a fixed point, which is hk. Okay, so essentially what is going to happen here, and I think this picture's already drawn for you, but I'm going to draw it as we go here. You have a fixed point h, k. Okay, then after you have your fixed point, you have a bunch of other points. This set, that essentially just means that it is a bunch of other points, and all those other points are a fixed distance r from A. So if hk is my fixed point, I'm going to have a fixed distance, and that fixed distance is r. And that's one of my points, xy. Okay? Well, I've got another xy point when I take that same fixed distance, r, for my fixed point, down here. There's another xy point. Okay? I keep taking this fixed distance r, and it's the same distance. That's a fixed distance. So each of these is the same distance. And every time I do this, I find another point. Keep forgetting my parentheses, sorry. So I keep taking that fixed distance, and I'm finding a bunch of xy points. Okay? Well, eventually, when you find an infinite number of these points, okay, all of these points start coming together because they're all a fixed distance. And then what shape does this take, since those are all the same distance away? If I was better at drawing. I'm sorry. But essentially, this should make a really nice and pretty, looking circle, which I was not able to do. Okay? So this fixed distance that they are talking about, this fixed distance, that is the radius of the circle. And this fixed point that they were talking about, the hk, hopefully from this picture, you guys can figure out that that fixed point is the center. Okay? So essentially what's going to happen is when you guys come up with these equations, you've got your hk, and you're going to have values plugged into that. You've got your radius, and you're going to have values plugged into your radius. Okay? So, those are going to have numbers in them, but then you're still going to have your x, y's just left as variables like we do in our lines. You know, if I have a line, I have y equals 2x plus 3. There's always an x and a y in there. Okay? But those are the essential parts of a circle that you have to know to come up with the equation. Okay? R is our radius, hk is our center. Here's a better picture of it. You've got all of these points, all of these xy points. They're all that fixed distance from R, and you just keep rotating that line around to find all of those xy points. Okay? Now, to come up with the equation of our circle, we're going to use something that you guys have used before. I don't believe we talked about it this year, okay, but it is called the distance formula. And the reason is that the distance formula can take a point and another point, and it will tell you what the distance is in between. So the distance formula actually works out really well for coming up with the equation of a circle. Okay, so starting out with, I have d equals the square root of x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. Okay, hopefully that equation looks familiar to you guys. I know you've done that in Algebra 1. Okay, but so starting out with, we've got our circle, and we knew that we had x and y, okay, and that was an infinite, that was a whole set of points. There's a bunch of those xy points. We have one point that is h and k. So we could say that this is point 1, and this is point 2. Okay? And then the last thing that we have is we have our radius. My spelling is atrocious today. I'm sorry. Okay? So radius, we'll do that in green. Okay? So I'm going to plug in. I've got I've got equals, d equals, we'll do the d in a second, square root of x sub 1. So my first point, well, my first point here is just an x. So I've got x sub 1 minus my x sub 2 would be an h. So I've got x minus h squared plus, now we're going to my y's. My y sub 1 would be y minus my y sub 2 would be k squared. Okay? So I'm just using the distance formula, plugging it in just like what I normally do. Okay? Then the distance. Well, what is the distance between point 1 and point 2? Well, that distance would be our radius. So instead of having a d for that radius, we could put an r there. Okay? And this is almost, this right here is almost the circle formula. The only thing is that for this equation, they're not going to want to have a big old square root on it. So they want to get rid of that big old square root. How could we get rid of that big old square root? Well, I could square both sides. And when I square both sides, I get r squared equals x minus h squared plus y minus k squared. And that right there is the standard form of a circle. Okay? You guys will also see it written as x minus h squared plus y minus k squared equals r squared. So, I mean, it really doesn't matter which side the r is on, but both of those are going to be your standard form of a circle. Okay? The next video that we do, we're going to look at this standard form. I'm going to show you guys how to graph it. And then on our last video, we will go from the graph of it and start putting it in these circles.